Do parallel universes really exist? Level C1. Advance. For centuries, humans have looked up at the night sky and wondered whether our universe is the only one. Are we truly alone in the vast darkness? Or is our reality just one version among many? Today, thanks to modern physics and cosmology, the question of parallel universes is no longer science fiction. It has become a serious topic of scientific debate. Although we have no direct evidence yet, many theories suggest that multiple universes could exist. Some may look like ours, some may be completely different, and some may be impossible for humans to imagine. 1. Why the idea of parallel universes exists. The concept of parallel universes, or the multiverse, tries to answer a simple but profound question. Why is our universe the way it is? The laws of nature, gravity, electromagnetism, the speed of light, are extremely precise. If any one of them were slightly different, life might never have appeared. Some scientists argue that this fine-tuning cannot be a coincidence. One possible explanation is that there are countless universes, each with different physical laws. We live in the one that happens to support life. This idea may sound philosophical, but several scientific theories lead naturally to the possibility of a multiverse. 2. The many worlds interpretation of quantum mechanics. Quantum mechanics, the science of very small particles, is full of strange behavior. Particles can be in several states at once, and only when measured do they choose a state. But why should measurement change anything? This mystery has confused scientists for decades. In 1957, Hugh Everett offered a bold solution. Particles don't choose the universe splits. Every time a quantum event has multiple possible outcomes, the world divides into parallel branches. In one universe, an electron spins up. In another, it spins down. In one universe, you wake up early. In another, you hit the snooze button. This is known as the many worlds interpretation, MWI. It suggests that there are infinite versions of you. Every possibility exists somewhere. The universe is constantly branching into new realities. MWI removes randomness from physics. Everything happens, but in different universes. 3. Bubble universes and cosmic inflation. After the Big Bang, the universe expanded incredibly quickly, a process called cosmic inflation. Many scientists believe inflation did not stop everywhere at the same time. Instead, different regions of space may have expanded at different rates, creating bubbles. Each bubble could be its own universe, with its own laws of physics. We live inside one bubble, but there could be countless others, separated by vast distances that no spacecraft could ever cross. These bubble universes might have different types of atoms, different dimensions, completely different physical laws, no stars at all, or even more complex matter than ours. In this model, the multiverse is a natural consequence of how space expanded during the early moments of time. 4. String theory and extra dimensions. String theory is an attempt to unify all forces in the universe. It proposes that the fundamental building blocks of reality are not particles, but tiny vibrating strings. Strings need more than 3 dimensions to exist, usually around 10 or 11. If extra dimensions are real, they might contain entire universes. In some versions of string theory, our universe is a 3-dimensional surface floating inside a higher dimensional space. Other universes may float beside ours, like sheets of paper stacked together. Occasionally, these universes might collide, creating events similar to our Big Bang. This idea suggests universes can interact. Universes might be born and destroyed. Reality is much larger than what we see. Although still unproven, string theory is one of the most mathematically rich models supporting a multiverse. 5. The simulation argument. The multiverse does not have to be physical. Some philosophers and scientists argue that our universe could be a simulation created by an advanced civilization. If one simulation is possible, then many may exist, each with different parameters and histories. Under this scenario, parallel universes might include failed simulations, experimental universes, alternate timelines, digital versions of possible worlds. This argument is controversial, but it shows how the idea of multiple universes crosses the boundary between physics, philosophy, and computer science. 6. Are parallel universes just science fiction? Many people know the idea of parallel universes from movies, books, and TV shows. In fiction, characters travel between universes easily, meet alternate versions of themselves, or experience different timelines. In reality, things are more complicated. Science does not claim that we can travel to parallel universes. It simply suggests that they might exist based on mathematical models and physical theories. Because we cannot see or measure other universes, the concept remains speculative. However, the fact that serious scientists consider the possibility makes the idea far more than fantasy. 7. Evidence? What could we look for? Direct evidence of other universes is extremely difficult to find, because they might be separated from us by barriers we cannot cross. Still, some scientists are searching for indirect signs, such as imprints in the cosmic microwave background. If another universe collided with ours in the distant past, it might leave a circular mark in the background radiation left from the Big Bang. Unusual gravitational effects. Other universes might influence our universe through gravity, since gravity can pass through dimensions, according to some theories. Strange quantum behavior. If quantum particles interact with parallel worlds, it might affect their probabilities in measurable ways. So far, no clear evidence has been found, but research continues. 8. Why parallel universes matter. Even if we never find proof, the idea of parallel universes is important because it helps scientists explore deep questions. Why does our universe have the laws it does? Why does life exist at all? Is our universe unique or ordinary? What is the true size of reality? The multiverse encourages scientists to think bigger and consider possibilities beyond our current understanding. 9. Infinite universes and infinite possibilities. One of the boldest ideas is that the number of universes could be infinite. If this is true, then every possible version of reality exists somewhere. There could be universes where dinosaurs never went extinct. Humans evolved differently. Earth never formed. Physics works in unfamiliar ways. Time moves faster or slower. There might even be universes where everything is the same as ours except for one tiny detail, such as a different weather pattern or a different color of a leaf. And somewhere, there might be universes where another version of you is reading a different book or living a completely different life. Infinity creates astonishing possibilities. 10. The philosophical side of the multiverse. Parallel universes raise deep philosophical questions. What does it mean to be you? If many versions of you exist, is your identity fixed or flexible? What is choice? In the many worlds interpretation, every choice creates new universes. Does that make free will an illusion? What is reality? If other universes exist but cannot be observed, should we consider them real? These questions show that the multiverse is not just a topic for physics, it also touches psychology, philosophy, and even spirituality. 11. The role of mathematics in the multiverse. Parallel universes may sound imaginative, but much of the discussion comes directly from mathematics. In modern physics, equations often predict possibilities that seem strange or impossible, yet they appear naturally from the math. For example, the equations describing inflation imply endless pocket universes. The formulas of quantum mechanics support the idea of branching realities. Solutions to string theory require multiple dimensions and possibly many universes. Physicists do not invent the multiverse to be creative. They encounter it while trying to solve problems. In fact, some scientists say that avoiding the multiverse requires forcing the math to fit our expectations rather than letting it speak for itself. This raises a fascinating question. If mathematics suggests the existence of parallel universes, should we trust the math even without direct evidence? Some researchers say, yes, after all, many scientific discoveries were predicted mathematically long before they were observed, such as black holes. Others argue that without proof, these ideas are interesting but speculative. 12. Levels of the multiverse, from simple to extreme. Not all multiverses are the same. Physicist Max Tegmark described 4 different levels of multiverse theory, each more abstract than the last. Level I: distant regions of our universe. This version suggests that our universe is so large it may contain regions we can never reach, perhaps with different histories or outcomes, simply due to randomness. These are not separate universes, just faraway zones. Level 2: Other bubble universes. This is the inflationary multiverse, countless universes with different physical constants. Level 3: Many worlds of quantum mechanics. This level describes branching realities created by quantum events. Every possibility is realized in a separate universe. Level 4: Mathematical universes. This is the most extreme version. Any universe that can exist mathematically does exist. In other words, any logically consistent reality is as real as ours. These levels move from scientifically grounded ideas to philosophical speculation, but together they show how broadly the multiverse concept can stretch. 13. Could parallel universes explain dark matter? Dark matter makes up most of the mass in the universe, but we cannot see it. We only know it exists because of its gravitational effects. Some scientists wonder if dark matter might come from a nearby parallel universe whose gravity leaks into ours. One theory suggests that dark matter is ordinary matter from another dimension that interacts with us only through gravity. This is difficult to prove, but it could solve one of the biggest mysteries in modern physics. If true, then parallel universes are not distant or imaginary. They may be directly influencing our world. 14. Black holes as gateways. Black holes have always fascinated scientists. Their gravity is so strong that not even light can escape. But what happens inside a black hole? Some theories propose that black holes could act as bridges or wormholes, connecting different regions of space or even different universes. The idea is speculative but intriguing. A star collapses into a black hole in one universe. Its energy might emerge as a big bang in another universe. This creates a chain of connected universes, each giving birth to another. In this model, our universe might be the child of a black hole from another universe. While we cannot test this idea directly, it helps scientists explore the possibilities of cosmic origins. 15. What would parallel universes look like? If parallel universes exist, they might look nothing like our own. Some could resemble familiar physics, but with slight differences, such as a stronger force of gravity or a slower speed of light. Others would be unrecognizable. Possible differences include different numbers of dimensions, 2, 4, or more. Different chemistry, no carbon, no water, no stars. Different physical constants, making life impossible. Different timelines, where events unfold in new ways. Completely abstract universes, based on mathematical rules unlike anything we know. Some universes might be extremely simple. Others might be far more complex. There may be universes without atoms, without time, or without space. 16. If parallel universes exist, why haven't we found them? The biggest challenge is that parallel universes, by definition, lie outside our observable reality. Our tools, telescopes, detectors, satellites are designed to explore our universe. They cannot easily look beyond its boundaries. Here are some reasons detection is difficult. Distance. Bubble universes may be separated by regions of space we can never reach. Dimensional barriers. If universes exist in higher dimensions, we may be unable to access them. Weak interactions. Parallel universes may influence ours only through gravity, the weakest force. Timing. The universe may not have collided with another universe recently enough to leave detectable traces. Scientists are trying indirect methods, but these require extremely sensitive instruments and careful interpretation. 17. The human fascination with other worlds. Even before modern physics, people imagined parallel worlds. Ancient myths, religious stories, and philosophical texts often describe alternate realities, heavens, spirit realms, dream worlds, and afterlives. The idea of multiple worlds taps into something deep in human imagination. People wonder, what if life had gone differently? What if there are other versions of ourselves? What if reality is bigger than we think? Parallel universes offer a way to explore these questions scientifically, rather than only symbolically. 18. The danger of over-interpreting the multiverse. While the multiverse is a fascinating idea, Some scientists warn against using it as a catch-all explanation. If every possible universe exists, then anything can be explained. Predictions become hard to test. Science risks losing falsifiability. Good theories must be testable. If parallel universes cannot be tested, can we call them science? This debate shows the tension between imagination and evidence in scientific research. 19. Could humans ever visit a parallel universe? Science fiction often shows characters jumping between universes as easily as stepping through a door. But is this possible? Current science says no. Travel between universes faces huge obstacles. Lack of physical connections, enormous energy requirements, no known technology to cross dimensions, possible instability of alternate realities. Still, future discoveries could change our understanding. 100 years ago, black holes and quantum tunneling seemed impossible too. For now, parallel universe travel remains purely fictional but inspiring for scientific curiosity. 20. What if parallel universes influence our lives? Some speculative ideas suggest that decisions in one universe might affect versions of ourselves in another. While this is not supported by mainstream science, it raises interesting questions about identity and choice. If the many worlds interpretation is true, then every decision creates new realities. Every version of you continues living its own life. The you reading this is just one example out of many. This leads to philosophical reflection. Are we truly unique? What makes this version of reality special? Does meaning depend on being the only one? These are difficult questions, but they show how the multiverse affects more than physics. It touches our understanding of ourselves. 21. The multiverse and the future of science. As technology improves, new discoveries may bring us closer to understanding whether parallel universes exist. Future progress may come from advanced gravitational wave detectors, improved cosmic microwave background analysis, particle accelerators, quantum computers, deeper mathematical models. Even if we never detect another universe, studying the possibility pushes science forward. It forces researchers to rethink assumptions, explore deeper questions, and expand our vision of reality. 22. Why the multiverse matters. Whether or not parallel universes are real, the idea matters for several reasons. It expands our imagination. Thinking beyond our universe helps us question limits and explore new ideas. It challenges our sense of importance. We may not be the center of everything, just one small part of a larger cosmic structure. It helps explain fine-tuning. The universe may not be special. It may simply be one of many. It connects science with philosophy. The multiverse bridges physics, cosmology, metaphysics, and human meaning. Exploring the idea helps us understand not only the universe, but ourselves. 23. The multiverse as a mirror. Parallel universes invite us to reflect on our lives. Even if they never exist physically, they exist as metaphors. Alternate paths. Missed opportunities. Different choices. The endless potential of life. Thinking about other versions of ourselves can inspire us to make better decisions, appreciate what we have, and imagine what we might become. 24. Scientific humility, accepting the unknown. The multiverse reminds us that science is not finished. There are mysteries we cannot solve yet, and perhaps never will. The universe may be far bigger, stranger, and more complex than our minds can fully grasp. This humility is healthy. It keeps science moving forward. It reminds us that curiosity is more important than certainty. 25. Conclusion. Are parallel universes real? The honest answer is, we do not know. But many theories, quantum mechanics, cosmic inflation, string theory, and advanced mathematics strongly suggest that they might exist. Perhaps. Parallel universes are everywhere, but invisible. They are the natural consequence of cosmic laws. Reality is far larger and more diverse than we ever imagined. Or perhaps we are truly alone in a unique universe. For now, the multiverse remains one of the most exciting possibilities in science. It challenges our imagination, expands our understanding, and pushes us to explore questions that lie at the edge of knowledge. Whether or not parallel universes are real, the search for answers tells us something profound. Human curiosity is infinite, just like the universes we dream about.